Welcome back. Last section we introduced the trig functions, right? And remember, we have this concept of a function. So this might be a little bit of a review for you. If you are kind of glancing through this and you're like, okay, I understand it, great, you can move on. But for those of us that maybe want a little refresher on what a function is, this is where you should spend a little bit of time. So when we use the language of functions, that means something very particular in mathematics. Before we have a function, we actually need to back up and talk about the concept of a relation. Okay, and a relation, you can see the definition here. It says a relation in x and y is a set of ordered pairs, and really that's all it is saying, is that the x and y are connected in some fashion. Okay, that's all a relation is. Okay, when we look at that set of ordered pairs and we look at all the x values we have in those ordered pairs, those x values form what we call the domain. Okay, so you might be familiar with the current and the concept of a function. All the inputs are x's. Well, yes, and when we have a function, that's true. But more generally, it's just the set of all x values or all values in the first position of the ordered pair that we have. Okay, when we look at all the set of y values, again, that would be the second position values in the ordered pair. Those are our range values. Okay, and again, when we have a function that's, all the outputs, we'll get there. Okay, now, once we have a relation and we can, of course, identify domain and range, we'll get to this in a moment, is that we have this concept of a function where if we're looking at this relation and we can say that for every value of x, or for each value of x, there's exactly one y. Okay, so if you could imagine there's x, like x1, x2, x3, like these are all different x values that you might have. And then we can say for each x value, there's one y value. So this might be y1, y2, y3. And just to change it up, I'll maybe do it something like this. But if we have something like this would be a function. Okay, where each x goes to one y. Okay, something where we run into a little bit of problem is, let's say we have that same sort of setup. We have just 3 inputs and I have 3 outputs, y3, and so it says for each value of x there's exactly one y. If we have something like x1 going to 2 different things, we're going to run into problems. Okay, we could have all x's going to y2, for example. That is okay, but where we run into trouble is this single x going to 2 different y values. Now, this would indicate that this is not going to be a function. Not a function. Okay. Now, some of you might remember there was some like graphical way of remembering this. That's true. If we had, so something like in the function case, if we had, I'm just going to make a quick sketch. If we had something like this going on, so this is y is equal to f of x, what we can do is we can take and pass a vertical line through any part of the function, and we're going to intersect at most one time. This is known as the vertical line test. If you need to do a quick Google search. If the vertical line passes, meaning that each vertical line intersects the function at most one time, then you're going to have a function. If you have a scenario where, well, the vertical line test fails, so again, something like, well, we saw the unit circle recently. Let's look at the unit circle. Okay, if we take and pass a vertical line through there, we actually have the vertical line intersecting in 2 places. This is going to be an example of a scenario where we don't have a function. We still have a relation. That is perfectly fine, but it just doesn't have this additional property of being a function. Okay, so the unit circle, while we can graph it and make a nice pretty picture, it is not actually a function. Okay, there are ways to get around this in mathematics, and we can be kind of clever, but for right now, let's just say the unit circle is not a function. Okay, and since a function is first a relation, a function has a domain and range. How do we find it? Well, we did say that the domain is all x values, range is all y values. So at least in terms of a function, if this notation is saying we put x in and we get y out, right? So we have to think about, in that case, what are the possible values for x, and then what are the possible values for y? What do we get out for y? Algebraically, it can be easy to find the domain, more easy, I should say, to find the domain than it is the range. The range could be a little tricky, okay? You've likely encountered a function like this before. This is called a rational function. And so in these cases, what we have to do is we always imagine that for the domain, okay, and this is my shorthand notation. I do domain of whatever function I'm working with. These things are the same. But for this, we're always going to imagine we have all real numbers. So this is my shorthand, well, math shorthand for all real numbers. So I can have everything except, and this is, so you translate this as except, and then I'm going to include like a list of things that I can't have. Now, some cases you don't have to remove anything, right? In cases where you have a rational function, though, we know that it is a cardinal sin in mathematics almost to divide by zero. Okay, so we cannot divide by zero. So we want to think about, in the case of where we have a rational function, where is the denominator 0? Oops, let me change that. Plus x squared equals 0. Okay, well, this boils down to doing some algebra. 4 plus x, and then 2 plus x is equal to 0. So x is equal to -2 and -4. So these are values, and I should actually probably say cannot equal, because I don't want them to be those values, because otherwise I divide by 0. So we can write our domain like this. Now, in Connect Math, our homework system, and other places, they're going to say interval notation. So what you can imagine the same thing as is, I always imagine a little picture. I put 0 on the number line, and then I put my numbers here, -2, -4, and at these values, I cannot have them, right? So I'd have holes, but I'd have all other numbers. And sometimes this picture just helps me write the domain using interval notation. So I have kind of 1 piece, 2 pieces, and 3 pieces. Okay, and if you need a refresher on interval notation, please Google it. But the domain using interval notation would be -infinity to -4, that first piece. And then we'd have -4 to -2, and then -2 to infinity. And since it's all 3 pieces together, I want to union those. Okay, so this is another way to represent the domain using interval notation. The range here, the range is going to be a bit more challenging to do. And so for the range, what I tend to do is I look at a graph. I sort of cheat, and then I look at the y values. Okay. The way to do it analytically is you have to kind of think about function by function. And for a rational function class of functions, you would say the range is going to be all real numbers minus whatever your horizontal asymptote is. Okay. And so in this case, our horizontal asymptote is going to be at 1 when y is equal to 1. Okay. So again, in interval notation, it would be this. Otherwise, certainly type this function into, say, Desmos or another graphing utility, get a picture of the graph, and then here, range, you're looking for your y values. Okay, so analytically, we can find the domain by saying, okay, it's generally all real numbers except whatever makes the denominator 0, or, if you're working with a log function or exponential function, you might have to review the domain and range rules for those, okay? You have to do that on a case-by-case basis, but nevertheless, that's kind of our general algebraic approach. Look where it's 0, take it out. Okay, now, sometimes we can represent a function or a relation in graphical form, okay? And so this graph that is shown is a function, okay? So it satisfies the vertical line test, and it says determine the domain and range, right? Domain range and intercepts and find f of 1 and all x such that, okay, we got a lot to do. Okay, so we got domain. I'm just going to make a list so I remember. Domain, range, intercepts, f of 1, and I need to find x such that, that's my abbreviation for such that, f of x is equal to 1. Okay, so let's tackle these one at a time. Domain, right, is a set of all x values. Because normally when we list coordinates here for the corresponding to the function, we do it in an xy order, right? So domain is going to be all x values. So to find that, I'm going to start with the leftmost value. So I'm going to start over on this side and work to the right. So what's the furthest x value that I have over to the left? Well, it's going to be what, minus 1, 2, 3, 4. So I have minus 4. Okay, and then I remember there's something about parentheses and brackets. Let's leave that for the time being. And then I'm just going to continue and I'm going to say, okay, well, where's the next place I have some sort of wonky thing going on with the graph? Where do I have a hole? Where do I have a filled in hole? Something like that. It's going to be at 0. Okay, so I'm just continuing right. Have to pause at 0, okay, and then I start again at 0, and then the next place where I have to think a little bit is at 3, and then from 3 I would be able to go on, and this arrow over here means that it continues on forever. Okay, now there's something about brackets and parentheses. We use a bracket, like a square bracket, either one of these, to indicate inclusion. We use parentheses to indicate exclusion. Okay, so in this case, 4 is included because it has a solid dot. When I have an open hole, that means I have exclusion. Okay, and so then 0, so I'd have to do negative 4 to 0, stop, continue on after 0, go to 3, and then now at 3, technically, I have an open hole and then a closed hole. Okay, in this case, we actually can combine them because the open or the closed hole supersedes the open hole, and just continue on off to infinity. And infinity we never include because it's a concept, not a number. Okay. Range. So range, we're thinking y values now. So I start at the very bottom and work my way up. Okay, because that's how our y-axis is oriented. Okay, so lowest y value to highest y value. Okay, so range, lowest y value is minus 1. Continue on. So I'm now going up this way. Next place I have to pause is at 1. Okay, and then from 1 I go to 2 right over here, and then there's nothing between 2 and 3, but then I have 3 on its own. Okay, so range, okay, now let's think include or exclude. Negative 1 is included because it has a hole. Okay, now at 1, I have a hole, but then there's this other thing over here, right? If there's not a hole or dot indicated, we imagine that there's a solid dot. So that is actually included, okay, in both those cases. So remember, I have those things where I can include it. So it's actually, I just continue to 2, where I have a break, and then I union that with this chunk at 3, but it's just 3. How do I communicate just 3? Well, that's where we use set brackets, these braces instead. So that one's a little weird. We do have to just say it's 3 alone, nothing more, and then we can continue on. To intercepts. Intercepts are where we hit the axes. So if I'm looking at those, that would be this place, and well, it would be that place, but I don't have it, right? Because there's a hole there. So there's only one intercept at 1, 0. Okay. Next, when I use function notation like this, f of 1, that means I know x is 1. I'm asking for what is y, right? So when x is 1, and so I go, when x is 1, y is 0. Okay. And now this next question is reversed. It's saying, okay, I know y is 1, what is x? So here's when y is 1, And when y is 1, x is, well, that's a whole. I don't have anything, right? The other place would be right here. So that would be x is 2. Okay, and that would be my final answer there. All right. So a little quick refresher on functions. If you have more questions, I highly encourage you to review section 1.3 from the text. Go into Connect Math and then go to your ebook. But that section will have a lot more information about functions if you need a little bit of a refresher.